Hi, my name is Sheila Ochuboju. I am the new Executive Director for the Alliance for Science. And we're a global science communication initiative that is embedded within the Boyce Thompson Institute in New York State on the Cornell University campus. In the simplest terms, they're genetic scissors. They're scissors that look at the DNA genetic material and they can either delete, they can add, they can alter, but they work with material that's already there. So not introducing foreign material, but editing the information that already exists within the organism. The reason that we as human beings are as fit and as healthy and as resilient as we are is because nature is actually doing that all the time. It's actually saying, oh, this doesn't work, oh, things have changed, and it's always editing genetic material. In fact, gene editing, how it was discovered by Nobel-winning scientist Jennifer Doudna and her counterpart, is that they looked at bacteria. Bacteria does this all the time. So this is how bacteria is so resilient, because it says, oh, here's a foreign material. Okay, let me try and get to know what is in the genetics of this virus. And it snips little bits, puts it there, keeps it so that it recognizes it like genetic memory. Next time the virus comes, it says, aha, I know you, and it cuts it precisely. So it was looking at what nature already does, and through knowing that the scientists said, oh, we could actually replicate this system because this is a system that happens in nature. And they developed precision tools to do that. And it's extraordinary because now we can use it across the board. So we use it, we talk about it at Alliance for Science a lot around biotech, but it's very important in health, in precision medicine, and increasingly in future will hopefully help us to be healthier and reduce the costs of us being healthy. Many areas of application in medicine, but because we're in Africa, let me give you one that is personally important to me and to many Africans, especially Nigerians. So many Nigerians, about a quarter, have a trait called sickle cell trait. And sickle cell trait Sickle cell trait in itself, if you're a carrier, in itself confers resilience to you. So you may have malaria, but we tend to be protected from malaria. But should you marry somebody who also has the trait, there's a 1 in 4 chance that one of your children will have sickle cell, the disease. And about 300,000 babies are born every year with that. But what precision medicine has been helping to do is to know how that works. So this was discovered around the 1950s. The link between sickle cell trait and malaria was known. But it wasn't until about 2018 when scientists in America, the National Institute of Health, and actually African scientists, Dr. Charles Rotimi, began to look at precision tools that could be used in looking at sickle cell disease and looking at also developing what we now have is a vaccine for malaria. So the precision with which the tool can be used means that we can have hope that very soon diseases that have plagued humanity, muscular dystrophy, cystic fibrosis, Huntington's, can be helped by these scientific discoveries. But perhaps more importantly, this tool is now being used by African scientists on the continent to look at diseases that matter to us. Because generally, a lot of research is done on genomics, but not much on the genomics of people of African descent. In fact, the research done on people of African descent is about 2% of all the genomic material that is out there. So there's a lot of study on European ailments, European diseases, and then therefore medical advances in European issues. So, but what this technology gives our scientists is an opportunity for now looking at African diseases and hopefully finding cures. And these cures will not just help Africans, but they can help the world because we are the birthplace of humanity. We are the most complex, most diverse, and the discoveries that can be made here will actually benefit the entire world. It's actually a new area. So there are very few labs that are focusing on even just trying to get to know the differences in African genome, but having a tool like gene editing is going to help us advance very quickly, especially since the cost of doing this kind of research has gone down exponentially. We work closely with the International Institute of Tropical Agriculture. So we have a specific collaboration with them. So we're looking at diseases, well, not disease, we're looking at innovations to help agriculture. So we're also supporting the governance framework in the country so that when innovations are made, hopefully uptake and buy-in will be faster. So we work very closely with scientists like Lina Tripathi, who's been working on diseases that affect banana, maize, cassava, etc. But also looking at vaccines that are used against cattle and pigs, etc. So it's a tool that can be used across the spectrum. Here in Kenya, we work very much on agricultural biotechnology. GMOs have had a really bad press. And in some ways, I have to be grateful for the bad press, because if GMOs had not had such a bad press, I would have still been a scientist in the lab and I wouldn't have entered into science communication. It's because they had such a bad press that when I started my career as a scientist in Oxford, the entire European Union shut, there was a moratorium, and we were not able to continue our work and go to field trials. And so, because people have an innate visceral fear of anything that they eat, much more than injections, because we take vaccines all the time, we take medicines all the time, and we're much more, I guess you can weigh the risk. Is, I have this disease, I'm suffering terribly, there's this technology, I don't understand it, but I'm willing to take a chance. People are willing to take a chance on technologies when it comes to health, but they're not willing to take a chance when it comes to food. And I've wondered about that for a long time, but because food is not just, food is culture, food is ritual, food is a sense of, the food that we eat defines each of us in our region. So there's something almost sacred about that. And so people have fears about GMOs, and yes, their fears are unfounded in many, well, they are unfounded because it's been proven safe in the last 20 to 30 years of actually the world eating these crops. But that doesn't mean we shouldn't listen. We should listen, and we should communicate better and take people on a journey of understanding and making choices that they are absolutely comfortable with. So that's what the Alliance for Science does, is just to help people to look at the choices. Now, with gene editing, in the UK, just before I came, when I started this job, and I was so excited that, as I said, over 25 years, there's been a moratorium, and genetically modified foods have not been on the market. But then I'm lying in my living room and I hear a report on BBC that gene-edited tomatoes are coming on the market. And what's exciting about that is that they're vitamin-enriched, vitamin D. So now every day I take vitamin D tablets because I've lived in the UK, I've lacked sunshine for decades, and it's now affecting my health. So every day I have to take vitamin D. And most of the UK population are being told, you must take vitamin D. It strengthens your immune system, and they've realized that it's almost a magic bullet. They were like, everybody has to take it. But it's actually quite difficult for your body to metabolize. And so researchers have now put vitamin D into the tomatoes, so vitamin D enriched tomatoes. And so with one tomato, you could have enough vitamin D that you would now, so you wouldn't need to take a tablet. And this is really wonderful. So the health of the population is going to be enhanced by things like this. Just like during the post-war period in the UK, where milk was fortified with vitamins and all of that to prevent stunting and other diseases. So a whole generation benefited from enriched food. So GMOs, I think maybe in the early stages, because GMOs were being adopted for commercial reasons to help the packaging, to make them ripen at a particular pace. They were not really looking at what consumers care about. Does it taste good? Is it nutrient dense? But now the new crops that are coming out are listening to consumer needs, and the technology is being used to respond to that. So we're hoping that it ultimately changes people's views, and the technology is given the space to grow, which it has to in Africa for us to have enough food.
So there's some positive.
I would say not some positive. There's a lot of positive, and I think the luxury of saying, well, you know, I don't know, it's a nice technology, but I'm not going to use it, is, I think we're seeing now the urgency that we don't have that time. We need to look at what technologies can we use to make sure that our crops are not ravaged by disease, to make sure tolerant to drought. Climate change is ravaging our continent. Our population is growing exponentially. How will we feed our children and grandchildren? We're not going to do so with the kind of agricultural systems that we have now and the kind of technologies we have. We need new technologies. And so adoption of that on the African continent is imperative. We have to accelerate understanding. Yeah.
What of CRISPR?
One of the technologies within the portfolio of gene editing. So it's another way of doing gene editing, and it's very precise. It's interesting, and it's just applied in the same way as other gene editing technologies. So CRISPR is being used a lot in medical innovations. There are people who worry about its precision. They worry about the ethical implications of, if you now have a technology that can very precisely eliminate diseases and disabilities, does it mean that we'll enter a world where people without disabilities exist? And that's a valid question. It's a valid fear. That's why scientists should not work in isolation. That's what science communication comes to do, is to create the place where science and society comes. And we say, we have this lovely technology, we could do this, and then you say, but actually these things that you think are defects and disabilities, we see them as enriching our society in certain ways, and we are not going to apply it to eliminate those. It's not the scientists that are going to make the decision. It's going to be you and your governments that say, we're not going to use it for this or this or this because we don't think it's right. The scientists just offer a technology, and I think citizens should be much bolder in saying, thank you for letting us know. Our tax dollars paid for you to go to school, make these discoveries, we're grateful. Now let us make a decision about what we do next. You have that power.
Is there support from the West to make sure this actually happens?
There is sadly very little support. There are some standout public and private initiatives. There's one in Nigeria called 54Gene, which is looking at the genome of 100,000 Nigerians, and it's a commercial private enterprise. And then there's some public ones. There's one called H3Gene or H3 Africa, which is publicly funded by the National Institute of Health in America and the Wellcome Trust. Wellcome Trust is one of the biggest funders of biomedical research across the world. And so they're being supported to do some work, but really nowhere. It's a trickle. Because Well, it's self-interest. Every society invests to take care of itself. We are 54 in terms of our continent countries. And if you look at how little we've invested to understand our own genetics, we being the birthplace of mankind, how little our governments have invested, it's really shocking. It's not for it's wonderful for international collaboration to support the work in Africa, but it is for us to be most concerned and most interested in knowing ourselves and looking for innovations that will help us. So our government should invest more in research on the African genetics and looking for cures for African problems and diseases.
So what's the future of gene editing? How does it look like?
Well, you know, I'm first a scientist and an optimist, so perhaps I'm not going to give you an unbiased opinion. I'm always optimistic. I'm optimistic because I feel that we carry within us all the answers that we seek. I always say that the answer is always contained within the problem. And if you define a problem well enough, you will find the answer. And gene editing is an example of the answer being contained within the problem. And so I see now the only thing once we have these precision tools and we make decisions about how we can use it across the spectrum in health, in agriculture, in even gene editing in conservation. A friend was telling me that he went to watch the new Jurassic Park movie, and he was like, wow, now I'm really understanding science and about genetics and gene editing, because it was like, if you had the power to bring back the dinosaurs, would you? You know, things like that. So I think it's that kind of quest that drives scientists and makes us really excited. And it's for society to work with scientists to say, okay, we're ready for this innovation at this stage, maybe not for this. And so the checks and balances are in that compact. But I see the future as being extraordinarily bright. We've reached the tipping point. It took us centuries to, first of all, sequence and then to understand what it means. Now we're beginning to reap the benefits of what scientists did for all of those years in the sequencing. Now we can decide what to do with it. So I'm excited about the future. We talk a lot about leapfrog development, and I think this is the time to leapfrog. We've got the technology to leapfrog. We've got the human capacity in terms of the numbers of young, vibrant, educated, passionate Africans who can see the world. We can see the world in a way we never could see the world before. It's open to us. The ways we could live differently are open to us. We don't have the legacy of bad infrastructure, because largely we didn't have that infrastructure. We see it in mobile phones. We didn't have the poles for us to have phones in our house. So when the mobile phone came, we leapfrogged. But other societies were now saying, but we already invested so much in this legacy. How do we move to the next phase? So in everything, infrastructure, medicine, everything, I see an opportunity for Africa to leapfrog into what we know will be the fourth industrial revolution. And genetics, gene editing, and all of these technologies will be right there in the fourth industrial revolution.
Thank you very much.
Thank you so much.
Anything else you want to add?
No.